And another great tool is from NVIDIA. Ilan Be'er is, sorry?
Okay, so it's Ilan Beer, and I hope I'm not
Beer.
the only beer here.
So Ilan Beer. So he's solution architect at NVIDIA, and he's going to talk about Isaac Simulator, specifically for robotics, right?
Yep.
So he's going to give us talk about that. So it's also a very important tool. So here you go.
Okay, so first of all, I'm happy to be here in Israel Robotics. And my name is Ilan Beer. I'm a solution architect in NVIDIA. In the Inception program, we're helping startups with their technology and with other things. And I'm here to convince you that Israel Robotics community can benefit from using NVIDIA. And NVIDIA is the world's leading AI and simulation platform. And when I mean platform, I mean that we actually have the hardware and a full stack of software. The hardware is either on the cloud for simulating or on the robot, mounted to the robot, like Jensen, other types of hardware. And when I'm talking about the simulation, so I'm talking about everything that has to do like related to like gaming, rendering, ray tracing, physics simulation, CAD applications. AI is another thing that a couple of years ago, like 10 years ago, scientists saw that the hardware of graphics programming units are very good for general purpose programming units. So it transferred, and the whole hype of deep learning is running now on NVIDIA's card, and also we have also inferencing in that field. So these two fields are very, very critical when you're going and you're trying to build smart robots. Now, a bit about me, I've been working in NVIDIA. I've been working playing around with NVIDIA's technologies for like the past 20 years. Fortunately, they hired me to play with their technology like 4 months ago, so I'm happy to continue. And I'm coming from both of these fields. So I was doing medical simulations, running on as a graphics programmer, and using the NVIDIA PhysX. And then I shifted to the field of like sports broadcast with computer vision in the areas of CUDA and accelerating and decoding and encoding of video. And my last position was deploying and creating in the autonomous vehicle a multi-stereo depth neural network from the cloud, quantization, pruning till the deployment on the chip. So both of these fields, also deep learning and also simulation, also AI and also simulation, I'm kind of familiar with. So at this talk, I'm going to try to show you 3 robots that what's interesting in them that they're all deployed. Yeah, the first one is Animal, and I'm going to take it as an example of Isaac Gym. Isaac Gym is reinforcement learning. The second example is Festo, where it's a collaborative robot with humans. And I'm going to give an example of a Cortex, how we use Cortex with Festo. And the last one is Oblix, which is AMR. And Oblix is I'm going to give an example using it as how we use a replicator and generating synthetic data. So let's begin. Oh, okay. Yeah, the sound. How do you fix the sound here? You didn't share it. Can you fix the sound? No, when you do sharing. לא, אתה צריך, כשאתה משתף, אתה מראה. אתה צריך להוריד את השיתוף, ואז להחזיר אותו, וללחוץ על זה Teams. כן, הוא מאוד קריטי. Technical issues. Yeah.
Successful development, training, and testing of complex Successful development, training, and testing of complex robots for real-world applications demand high-fidelity simulation and accurate physics. Built on NVIDIA's Omniverse platform, Isaac Sim combines immersive, physically accurate, photorealistic environments with complex virtual robots. Let's look at 3 very different AI-based robots being developed by our partners using Isaac Sim. Fraunhofer IML, a technology leader in logistics, uses NVIDIA Isaac Sim for the virtual development of Obelix, a highly dynamic indoor-outdoor autonomous mobile robot, or AMR. After importing over 5,400 parts from CAD and rigging with Omniverse physics, the virtual robot moves just as deftly in simulation as it does in the real world. This not only accelerates virtual development, but also enables scaling to larger scenarios. Next, Festo, well known for industrial automation, uses Isaac Sim to develop intelligence skills for collaborative robots, or cobots, requiring acute awareness of their environment, human partners, and tasks. Festo uses Cortex, an Isaac Sim tool that dramatically simplifies programming cobot skills. For perception, AI models used in this task were trained using only synthetic data generated by Isaac Replicator. Finally, there's Animal, a robot dog developed by a leading robotics research group from ETH Zurich and Swiss Mile. Using end-to-end GPU-accelerated reinforcement learning, Animal, whose feet were replaced with wheels, learned to walk over urban terrain within minutes rather than weeks using NVIDIA's Isaac Gym training tool. The locomotion policy was verified in Isaac Sim and deployed on a real Animal. This is a compelling demonstration of simulator training for real-world deployment. From training perception and policies to hardware in-loop, Isaac Sim is the tool to build AI-based robots that are born in simulation to work and play in the real world.
So when we want to do end-to-end robotics with NVIDIA off the shelf, so Isaac is a great way to use it, because Isaac has also training and simulation, building and deployment. Now, these 4 pillars, everybody understands why building a robot and deploying it is important. It's really complicated, and it's something that you guys that working with the hardware understand. But why do I need a simulation and training? So a critical thing is that we want to develop the robot even if we don't have the parts. So sometimes we want to like simulate the physics of the robot or kind of change it, and that's why we have simulation. Now, sometimes also when we're training things, we want to get to crazy like scenarios where the safety is problematic to drive a real robot there, and that's what we have Isaac Replicator. So Isaac is the whole tools and platform, and I'm gonna focus on simulate and train. So just something to like talk about Omniverse, which is kind of confusing because it might like ring a bell with metaverse, but it's a critical thing in understanding 3D content. Now, whoever tried to play around with simulations like, I don't know, Gazebo or Unreal, so you have in the robotics community, URDF or step files, the problem of versioning 3D content files that create your robot, taking it from a robot from GrabCAD and downloading it and lifting it with Onshape makes it really problematic from the conversion point of view and the versioning of the file itself. So NVIDIA, like back a couple of years ago, was thinking about how to create this internet of 3D so people can collaborate with the same content, with the same 3D content. And they thought about using a 32-year-old format of Pixar, and that's actually the USD that's based on the Omniverse. Now, Omniverse is the basic technology under the hood of everything that has to do with 3D content, and it's using the acceleration of ray tracing and also physics. So when you go into Omniverse, the first thing you want to download is the Isaac Sim, which is on top of the Omniverse. So when you download the Isaac Sim, which is pretty simple, so you have three things that I'd like to emphasize. emphasize. The connectors, you could connect your Gazebo or Unreal Engine. Say you have a company that one of the guys is working with a simulator of a Gazebo and the other one is working with Unreal. You can connect it. The whole pipeline is already there for you. Their server, the whole infrastructure is NVIDIA gives it for you with the software. Now, if you want to do a kind of scripting in Python, you have Visual Studio Code that you can be working with, or a Omnigraph, which is a visual scripting, and it's kind of easier to program and do workflows. So let's get back to the three topics that we wanted to talk about. So we'll start with Replicator, and then Jim and Cortex. So when I'm looking at Isaac Replicator, it's the main goal of it is generating synthetic data. And when you want to generate synthetic data, the question is why use Isaac? So two main things that I'd like to emphasize in Isaac in relation to other ways to simulate synthetic data is that we're connected to RTX, which is technology of NVIDIA. It's ray tracing in real time, which is the visual fidelity is very high, and the physics. So if you want to create a digital twin of your robot, say taking the parts and trying to connect everything together so it moves in the world accurately and physically, so that's exactly what they did. They created a digital twin, and then you could like test it on collision avoidance or even do training. But that's not the only thing in Replicator. We could also generate all kinds of different scenarios of the scene and randomize the ways and put all kinds of like edge cases on the area of the robot that it's training on for visual perception. What you get for free when you're using synthetic data is that all your data is labeled. So that's the benefit of a synthetic data. And when you're talking about like different sensors, so we give all kinds of different sensors. We give LiDAR point cloud, which is standard, fisheye, and all kinds of other things. If you want, you could also kind of customize your sensor on the way you want. So this is Replicator. Something that I want to mention now, but I don't want to get into in-depth to it because tomorrow there's going to be a session, there's going to be a workshop of robotics that's going to go into depth in it, is NVIDIA's Tau Toolkit. NVIDIA provides pre-trained models that are optimized on their hardware. So if you want to download the model, you could take it and then do domain adaptation on the specific environment that you want. Generate your synthetic data for your specific robot and do it. And it's kind of the best way to go with our hardware. Okay, Isaac, Jim. So reinforcement learning is part of machine learning. Yeah, the main thing about it is that there's an agent, and he does some kind of an action and in an environment, and he gets rewarded or punished. So here you see the animal like walking around the steps and trying to and it's very impressive. So I wanted to try this out, and first of all I looked into it and I saw, wait a second, reinforcement learning, it was out there before NVIDIA came. So what's the big deal about it? So the big deal about it is that 2021, what happened was that all the simulation steps that were done on the CPU, they kind of transferred to the GPU using physics and CUDA, and also the reward and observation. So the DNN, the network itself is all combined. So you're not moving or transferring the data from CPU to GPU, which is take long time to train. So the minute you do this, you're able to train. And I took my computer, I have a A6000, yeah, I'm lucky to have it. So I was able to train. And I downloaded the Git from the Git Omniverse, and you can see here it's kind of confusing. There's a Isaac Jim's environment, which is the previous version that people kind of used and played, but then there's the Omniverse. So I would recommend to download the Omniverse because it's connected with Omniverse. And what I did is I kind of trained the robot. So this is on my computer, yeah. So I trained the robot, they started walking. I mean, the way the terrain is done is that there's a flat terrain, kind of rigid, and then there's steps. And you see the robots were started after a couple of hours, they were started walking, and after 996 epochs, wow, this is amazing. I mean, and you don't have to have any experience with a reinforcement learning. You just need to have experience with coding. You have the samples. It's really cool. Okay. So we finally got to Isaac Cortex. Now, I have 2 minutes. Okay, so I'll do it fast. Okay, Isaac Cortex is in beta. It's not released yet, but it makes your your decisions, complex decisions, more easier. So if I'm looking at autonomous vehicles, you could see that robots are similar, but are in unstructured environments. They're working in unstructured environments. So on the left part, you have 3 layers. You have the perception layer that's getting all the sensors, and then there's the understanding, and then there's the logic, where the car decides to go from one place to another. But if you're trying to create a robot that kind of cleans up your 16-year-old kid's room, it's kind of problematic. So the new paradigm that NVIDIA decided was to, let me jump on this. It was to create a new API that works with decider networks. Decider networks are kind of like a state machine, but they have their memory where they got from. So the thing is this, you see this robot Festo, he's moving, someone's moving a block, and the gripper's going and taking it. And each time he's kind of looking at his state. Now, he really doesn't care where to stack the blocks. He doesn't have a preferred order, but just changing the algorithm or the logic of this is kind of complicated when you have a system that you just program. And what Isaac Cortex is doing, part of it is it's kind of letting you only change the difference on the leaves that are deciding of the order. Now, let me get to this. This is the more important part. The thing of Isaac Cortex is, think about it as the brain of the robot. And you could connect it to the real world, and it's getting the perception. On the level of the perception, think about it as the replicator, everything that has to do with computer vision. And then it's trying to understand the world model and the logical states, getting 3D objects and understanding what's on top of the other. Then there's the decider networks that I just jumped over before. I didn't have time. But and then the action of the decider networks are really simple. It's just take this box and put it to another place. Now, when you want to have intelligent policies, a good example is putting Isaac Gym inside. So Isaac Gym is like an intelligent policy. You're telling him to walk from on top of the steps to the elevator, but you're not telling him how to walk. So that's where Isaac Gym comes in. So this is my next game that I'm going to play with. It's the development kit, Orion AGX. And what I'm trying to say is that there's hardware in the loop. So everything that you saw, you could just program on this. And if you want any more info, tomorrow we're having a workshop, and I advise you to sign up. It's going to be talking in depth to all the stuff that I was talking about. And just come to me after the session, and you could ask me anything you want. There's Ilan here, lift up there. So that's it.